Hello, this is Mrs. DB, and today we are going to begin Chapter 4. Section 1 is a pretty simple one. It's on classifying triangles. And then the rest of the chapter will work on proving some different things about triangles and using that information to find missing parts of triangles. I do think the warm-up is a good idea today, so try these problems, make sure you remember them, and then we'll check your answers. All right, so for the first section, we're supposed to classify each angle as acute, obtuse, or right. You should know those quickly. Number 1 is a right triangle, number 2 is acute, and number 3 is obtuse. In number 4, if the perimeter is 47, you're supposed to find x and the lengths of the three sides. So you're going to write an equation. You know that the perimeter is the sum of all three sides. So you would write that 2x plus 6 plus x plus 3 plus 3x plus 8 is equal to 47. And then you combine your like terms, and you should have found that x was 5. Once you find what x is, you just plug it back in for each side, the expression for each side, and then you'll find out what you get for your lengths of your sides. And we find that these are the three lengths of our sides. So hopefully that was not too difficult, and now we'll move on to the objectives for our lesson today, which are to classify triangles by their angle measures and by their side lengths. There's two ways to classify triangles, and also to use these classifications to find angle measures and side lengths of triangles. All right, let's get going. Our vocabulary today is an acute triangle, equiangular triangle, right triangle, obtuse triangle, equilateral triangle, isosceles triangle, and a scalene triangle. So it's all different kinds of triangles. A triangle is a polygon with three sides. We worked on definitions with biconditional statements in Chapter 2 with that statement. Triangles can be classified in two ways, by their angle measures or by their side lengths. Okay, here we have a triangle. Let's see how we would classify that triangle. First we have to look at the side lengths of a triangle are made up of segments, so we would have segment AB, segment BC, and segment AC to make up that triangle. Remember, segments are drawn with the capital letters with a little line segment over the top. In Word, or if we're typing, we can abbreviate that to segment AB, or you can write out segment AB, because it's hard to draw that little line above if you're typing. So you either have to write the word segment or SEG is fine. The vertices of the triangle are A, B, and C. They're capital letters, very important. And now we'll start our triangle classification. When we want to classify by the angle measure, we have acute triangles, which would have three acute angles. Every single one of those angles is less than 90 degrees. We can have an equiangular triangle, which means that all three angles are acute but also congruent. Some of you may already be thinking in your head that you know what the measure of those are, and we'll work on that in a little while. A right triangle is when you have exactly one right angle. Only one. You can't have more than one. So one angle is 90 degrees, the other two will both be acute. And then finally we have an obtuse triangle, which means that one angle, just one again, will be greater than 90 degrees. So it looks like in this one, this angle is greater than 90 degrees. The other ones will both be acute. Here's an example of a problem that you might have on your homework assignment. It says to classify triangle BDC by its angle measures. Now be careful, because there's more than one triangle. There's actually three triangles in this picture. There's this little tiny one, there's this one here, and then there's the whole triangle that's made of the two together. The triangle that we're looking at is B, this vertex here, D, and then C. So it's the one that I have colored in red right now. That triangle has a 100-degree angle, and then not a 90-degree angle. That's the whole, that's ADC. So it's got one obtuse angle and two acute. So this is called an obtuse triangle because it has one obtuse angle. Did I say that right? It's an obtuse triangle because it has one obtuse angle. Okay, now this is the same picture, but now we're going to classify ABD, which is this little tiny one. See the little tiny triangle? So the little tiny triangle has an 80-degree angle and a 20-degree angle. It's hard to tell what the other one is, but it certainly does look like it's acute. Is there a picture that I cover up something? No, I see, that's 80. And this would be 80 as well, because if this is 100, then that's 80, and this is 20. So there's a linear pair right here. That's how I knew that was 80, because together it's 180 degrees. So the missing angle was 80, this angle is 80, and this is 20. So it's an acute triangle because all of the angles are acute. Okay, now we have to classify FHG. Now find that triangle. Here's F, here's H, and here's G. So don't just assume that it's going to be a right triangle just because one angle is right, because the triangle that we're looking at, there is no right angles. Okay, because it is a right angle up there, we know that there's 90 degrees in a right angle and that this part of it is 30. So 90 minus 30 is 60. So this angle right here is 60. So therefore we have 60 degrees, 60 degrees, 60 degrees. So we are going to call this an equiangular triangle. It's also acute, but a more specific name is equiangular. We can also classify our triangles by side lengths. You might remember this from maybe like middle school. We have an equilateral triangle, which means that every single side is the same length, congruent. So we have 3 congruent sides. We have an isosceles triangle, which means there's exactly 2 congruent sides, or it could have 3 because actually an equilateral triangle is also isosceles. So the definition of isosceles is at least 2 congruent sides. So it could have 2 or 3. We just call this, if it has 2, we say isosceles. If it has 3, we say equilateral. And a scalene triangle, no sides are congruent. They're all different lengths. When you look at a figure, you cannot assume that segments are congruent based on appearance. They have to be marked as congruent. Also, you cannot assume that you have a right angle unless it's marked as a right angle. We cannot assume that we have a right angle in this picture. We can assume that segment EF and segment HF are congruent because they have those little tick marks that show they're the same. We are supposed to classify this triangle by its side lengths, and it's triangle E, right here, HF. So it's not EHG, it's EHF. 2 sides are marked congruent. Therefore, it's an isosceles triangle. Okay, now let's look at EHG. All right, we have that this side here is 12, this side is 11, and down here we would have to add the 10 plus 4 together to get 14. All 3 sides have different lengths. None of them are congruent then, so it's a scalene triangle. Classify triangle ACD. I almost said B, so C is this one. So we're looking at, let me mark this triangle, ACD, this triangle, this skinny little one on the end. All right, so we know side CD, segment CD is 5. We know segment AD is 18. What about AC? Well, AC is marked congruent to AB, so this is also 15. So we have side lengths of 15, 18, and 5. None of them are the same, so it's scalene. All right, if we know some information about a triangle, like that sides are congruent, then we can find missing parts, like perhaps X or a side length. In this triangle, JKL, segment JK is marked congruent to segment KL. So by the definition of congruence, we know that JK, length of JK, will be equal to the length of KL. Or 4x minus, we can use substitution here to say 4x minus 10.7 is equal to 2x plus 6.3. So we knew that the sides were congruent, that was given, and that means that you know that their lengths are equal. And then you substitute in, and then you solve with, algebraic properties, and we end up with 2x equals 17, and then we divide and we get 8.5 is x. Now in this case they didn't ask us to find a side, so you would just leave your answer as x equals 8.5. Notice that we did not use this side at all. Sometimes students think that they have to stick every piece of information in order to find the answer. We never used side JL. It didn't help us at all. Here's another example. Oh, now they're changing it to find the side lengths of JKL. So now we're going to take, we found that x is equal to 8.5. And now we'll just substitute that in here, here, and here. However, some of you might have already said, wait, why do I have to substitute it into both 4x minus 10.7 and into 2x plus 6.3? You don't, because JK is the same length as KL. So you could just do it into 1 and then say that's the same. So we get 23.3 for JK, length of JK. KL, we better get the same exact thing, and you do. You could have saved yourself some time and just said that KL will also be equal to the same thing. And then JL, now we needed that expression, is 5 times 8.5 plus 2 is 44.5. Okay, here's another example. It says find the side lengths of equilateral triangle FGH. All three sides are given. See that? 3y minus 4, 2y plus 3, and 5y minus 18. It's equilateral, so all of these are the same. You just need to pick whichever two you like best. All the side lengths are going to be equal because of definition of congruent segments. Pick whichever two you like best. They picked FG and GH, which is 3y minus 4 and 2y plus 3. But you could have picked 3y minus 4 and 5y minus 18. Since you know they're equal, you just set up an equation where they're equal to each other and then use your algebra skills to solve and get what y is. In this case, they got y equals 7. And then we would have to plug back in and find the lengths of the missing sides. So now you take your y equals 7 and you plug it into each part, and you'll find your missing side lengths. Now, again, some of you may have said, do I really have to plug it back into each part? And the answer is no. This is an equilateral triangle. Every side's going to be the same. You could find the length of one of them and just say that if once you found FG, you could just say GH equals 17, FH equals 17. They're all 17. You do have to write what they are. You can't just put one answer, but you can skip a step. You can do it in all three, though, if you want to make sure you didn't make a mistake. Application problem. It says a steel mill produces roof supports by welding pieces of steel beams into equilateral triangles. Draw an equilateral triangle. First thing to do when you get a word problem, sketch it out. Each side of the triangle is 18 feet long. It's equilateral, so all three of these sides are the same. Label it. How many triangles can be formed from 420? Well, in just one triangle, I used up 18 plus 18 plus 18 feet. So that would be 18 times 3. 8 times 3 is 24, 3, 4, 5. So I used 54 feet for one triangle. So if every single triangle takes 54 feet, then you're going to have to take 420 and divide it by 54. So you can make 7 and 7/9 triangle, but they're not going to want 7/9 of a triangle when you're making a roof support, so the answer will just be 7 triangles. You can't have a triangle that's not correct at the end. All right, so that's it for today. I hope you have a good time doing this worksheet. Just the only key is to remember that look for the triangle that they tell you to. When they have overlapping triangles, don't just assume without reading carefully what triangle you're talking about. So like this one, it said classify triangle ACD. It might have said classify triangle ABC or ABD. So just read that carefully and make sure you pick the right triangle, and then I don't think you'll have any trouble on this lesson. Thank you very much and have a great day.